Hello everyone, this is Hazel Japan.
Hello, my name is Remy Lumbayan. I am Kirsinin Limbaga. And I am Jovijin Lumongo. And we are the group assigned to discuss the electroanalytical methods and its application. We are here to discuss the types of electroanalytical methods and application of electroanalytical methods. The electroanalytical methods use electrically conductive probes called electrodes to make electrical contact with the analyte solution. The electrodes are used in conjunction with electric or electronic device to which they are attached to measure an electrical perimeter of the solution. The measured parameter is related to the identity of the analyte or to the quantity of the analyte in the solution. The electroanalytical methods are divided into categories according to the electric parameters that are measured. There are many types of electroanalytical methods, but in our discussion, we choose the major electroanalytical methods, which includes potentiometry, amperometry, conductometry, and electrogravimetry. Potentiometry measures electric potential or voltage while maintaining a constant or normally nearly zero electric current between the electrodes. This illustration shows how potentiometry measures electric potential or voltage. Potentiometry is the method in which the potential between two electrodes is measured while the electric current, usually nearly zero between the electrode, is controlled. In the most common forms of potentiometry, two different types of electrodes are used. The potential of the indicator electrode varies depending on the concentration of the analyte, while the potential of the reference electrode is constant. Potentiometry is probably the most frequent used electroanalytical method. It can be divided into two categories on the basis of the nature of the indicator electrode. If the electrode is metal or other conductive material that is chemically and physically inert, when placed in the analyte, it reflects the potential of the bulk solution into which it is dipped. Electrode materials that are commonly used for this type of potentiometry include platinum, gold, silver, graphite, and glassy carbon. Amperometry. Amperometry monitors electric current or amperes while keeping the potential constant. During amperometric assays, the potential of the indicator electrode is adjusted to a value on the plateau of the volumetric wave, as during controlled potential electrogravimetry, gravimetry, and coulometry. The current that flows between the indicator electrode and the second electrode in the solution is measured and related to the concentration of the analyte. Amperometry is commonly employed in two ways, both of which take advantage of the linear variation in current at constant potential with the concentration of the electroactive species. A working curve of a current as a function of the concentration of a series of standard solution is prepared, and the concentration of the analyte is determined from a curve, or amperometry is used to locate the end point of the amperometric titration. An amperometric titration curve is a plot of current as a function of titrant volume. The shape of the curve varies depending on which chemical species, the titrant, the analyte, or the product of the reaction is electroactive. In each case of the curve consists of linear regions before and after the endpoint that are extrapolated to intersection of the endpoint. Conductometry. This is the method in which the capability of the analyte to conduct an electrical current is monitored. From Ohm's law, E equals IR, it is an apparent that the electric current I is an inversely proportional to the resistance R, which E represents potential difference. The inverse of the resistant is the conductance. G equals 1 over R. As the conductance of the solution increases, its ability to conduct an electric current increases. Electrogravimetry. Electrogravimetry, in which the solid that is read is deposited on one of the electrodes. Electrogravimetry was briefly described above as an interference removal technique. This method employs 2 or 3 electrodes, just as in voltammetry. Either a constant current or a constant potential is applied to the pre-weighed working electrodes. The working electrodes correspond to the indicator electrodes in voltammetry and most other electroanalytical methods. A solid product of an electrochemical reaction of the analyte coats the electrode during application of the electric current or potential after the assayed substance has been completely removed from the solution by the electrochemical reaction. The working electrodes is removed, rinsed, dried, and weighed. The increased mass of the electrodes due to the presence of the reaction product is used to calculate the initial concentration of the analyte.